live. Okay?
Don't break it, Ryan.
All right, here we go. So today's notes, let's start off with, what is it? Octobre 7. So our objective today is graphing linear functions with intercepts. Okay, graphing a linear functions with intercepts. Okay, let me go back, do a tiny little review. If it's a linear, it means it's a straight line. Right? So if we see the word linear, we know it's straight. That's linear, it's straight. And if it's a function, we also know that, function every x has only one y. For us, the easiest way to determine if it's a function, we like that vertical line. I like that vertical line. So just go anywhere down the line. I'll never hit it twice, right? That's not vertical line. So this is definitely a function. This line is. And it's straight. So it's a linear function, okay? Now, because we use an x-axis and a y-axis, that's why we say y equals, okay? You guys have seen that before, right? X-axis represents all the x's, y-axis represents all the y-axis, all the y values, so we use y equals, okay? So, let's take a look. Yeah, Ron.
I still need one.
Oh, I'm sorry about that. So if I take a look at what I gave you a picture, this is the x-axis. It represents all the x values along this point. This is the y-axis, represents all the y values. X is over, y is up, right? X-axis over, y is up, okay? Domain, range. So a linear equation is going to be, a straight line that is a function. Another thing that I want you to know, and that is that every linear function has an x to the 1 power. Now, the 1 is going to be invisible. In fact, take a look at example 1. Look at example 1. I mean, there's a 1 here. It's invisible, but that's an x to the 1 power, right? We don't need to really write it. But every linear equation is going to have like an x to the 1 power. Okay, so this one's definitely linear, okay? Now, the intercepts. Let's go and figure this out. The x-intercept is right there. Because that's my x-axis, it intercepts the x-axis. So my x-intercept is right here. And my y-intercept is right there. Okay, we're not going to make this hard. Intercept is where it goes through, right? Does that make sense? If I intercept somebody, just want to get them, okay? So it intercepts the x-axis at that spot. It intercepts the y-axis in that spot. Does that make sense, everybody? Okay, not too hard. Now, here's what we want to write, though. At the x-intercept right here, the y value is 0. See that? At this point right here, the height is 0. Does that make sense? Right here. Everybody see my pen? Right there, the height is 0. So the x-intercept, we let y equal 0. At the y-intercept, right here, y-intercept, you can see the x value is 0. There's no x. So at the y-intercept, we let x equal 0. Now let's figure out how to graph easy without having to do too much work. So what we've done in the past is we've used a t-table. And a t-table will work to graph this line. we use the t-table, right? And Artie says, I know, it's always pick on Artie, it's okay. Artie says, let's use 0, 1, 2, 3, right? And you make 4 points, dot, 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 you draw a line, right? Does that make sense? Here's what I know though. The line's straight, correct? The line is straight. How many points do I really need? I only need 2. I only need 2 points. You guys agree with that? If I get 2 points, dot, dot, line's done, right? So let's figure out 2 points, connect the dots. That's all we got. So we need just 2 points. So we're going to, the 2 points we're going to find are my intercepts. So first, if we want to graph this by intercepts, the x-intercept says let y equal 0. Okay, so my x-intercept, we're going to let y equals 0. Okay, so in my equation, instead of writing y, we'll put 0, okay? In my equation, instead of writing y, we'll put 0. So I'm going to write this. 3x plus 4 times 0 equals 12. So instead of writing my y value, I wrote 0. All right, that's easy. Anytime 0 is 0, correct? 4 times 0 is just 0. So I really get a 3x equals 12. Divide by 3. Divide by 3. X equals 4. That's a point. That's a point. 0 and 4. So x first. So my x-intercept is at 4, 0. I can graph that point. 4, 0 is right there. My y-intercept is when we let x equal 0. So now let's figure out our y-intercept. So we y-intercept x equals 0. So I'm going to go back and right here, instead of writing x, I'm going to write 0. So I'm going to write like this. I'm going to go, okay, 3 times 0 plus 4y equals 12. Because I just put my 0 in for my 3. Well, that's easy. 3 times 0 is 0, right? So then I get a 4y equals 12. Divide by 12, divide by 4, divide by 4, y equals 3. That's the point also. The point is 0, 3. I can graph that. 0, 3 is right there. I have a y-intercept and an x-intercept. All I need is 2 points to graph the line. So if I had a ruler, I would do it. Of course, I don't have a ruler. Oh, here's the ruler. Connect the dots. Now, pretty easy. Let me show you how much easier it could be, okay? I hate to teach this, but it's called the cover-up method. Watch. You watching? So if I cover up the x's, 4y equals 12, what's y equal? Boom. Y is 3. Cover up the y. 3x equals 12, what's x equal? X equals 4. Boom, wasn't that fast? Line done. How fast did that take me? That's so quick. So basically, if you cover it up, you can get it equal to 0, haven't you? Wrong? Yeah, okay. Okay, let's take a look at the next example. Thumbs up. Wasn't that easy? Just an easy way to graph a line. Okay, number 2. So, x-intercepts. So if I let x equal 0, I'd have a 2 times 0 minus y equals 4, right? Because put 0 right there. I'd have a negative y equals 4, but that's like a negative 1y. We don't normally write it. It's invisible, but it's there. So I can divide by negative 1, and I get y equals negative 4. So my y-intercept is 0, negative 4. Okay, now let's let y equal 0. So put 0 there. Well, you're here. 2x minus 0 equals 4. Good. Or 2x equals 4. Divide by 2, x is 2. Or we have a point at 2, 0. That's right there. And I connect the points. And there's my line. Now, you might be saying, Mr. Davies, you're doing a lot of work, and I agree. Would you like the cover-up method? I'm the teacher, so I'm going to teach the steps, right? I am the teacher, I will teach the steps, right? But if I cover up the y, what's x equal? 2, right? 2x, y, what do you got? 2. If I cover up the x, what's y going to equal? Negative. You guys see that? Okay, good. Okay, I will teach every step because I'm annoying and I'm the teacher because I want you to know why. Okay, turn the page. Okay. Now, y equals 3. These are special graphs. So I want you to write these down. These are special graphs. In fact, in our journal they show them too. So if you guys ever forget these, right? Take a look in our journal. I'll show you what pages it's on. 3, 4. I'll show you real quickly. Okay, there they are. Horizontal graphs and vertical graphs. So they're on our journals, right? So y equals any number is a horizontal graph. So here's my y-axis. I go up to 3. 1, 2, 3. Y equals 3. It's right here. If you forget this, let me show you how it works, okay? All right, ready? Right here, where my finger is. Everybody, what's the y value?
3.
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 Y is always equal to? What do you know? Okay. And then the other is a vertical line, and that's the x equal. So same thing, your journal shows that. Here's your journal. So if I have x equals negative 5, it's a vertical graph. So I'm going to go to 1, 2, 3, 4, 5. Oh, I went off my paper. It's all good. It's a vertical line. And again, same thing. What's the x value here? Negative 5. What's the x value here? What's the x value here? X is always equal to negative 5, right? Okay, those are our special graphs. Okay, little story problem. You're planning a banquet and you need to seat 180 people. Small tables seat 6 people and large tables seat 10. Oh, word problem sounds hard. Okay, so let x be the number of small tables. So I got x small, okay? X is my small, and my y is my big table. Okay, that helps. I know that when I go to this banquet, I'm going to have small and big, right? So the number of small plus the number of big should make the total number of tables, right? So if I want to make an equation, I'm going to start, okay, so I've got 6 is my small, so how about a 6x? 6 people per small table, plus we got to add in my big table, so 10 people can sit there, and I need to seat 180, so I can find out how many to put at each table, right? So let's look at our intercept. So x intercept. Okay, if I want to graph this, let me see. So that's going to be y equals 0, so I have a 6x plus 10 times 0 equals 180. I can have 6x equals 180. Divide by 6. Divide by 6, I think that's 30, okay? So we can have at most, think about this. We can have all little tables and no big tables, right? 30. We have 30 little tables and no big tables. But what if we have all big tables? Well, that's the y-intercept. Okay, so let's let y equal 0. I'm sorry, x equals 0. So I got 6 times 0 plus 10y equals 180. I've got 10y equals 180, right? Divide by 10. Divide by 10 is 18. So what this tells us is this. Okay, I want you to listen. Okay, what this tells me is this. We can have any combination. You okay with that? Any combination. If we want to just have all little tables, we can make 30. If we want all big tables, we can have 18. But we have a combination of both, right? So when we graph this, let's go ahead and put the graph down. So when I make my graph, I know I'm probably going to change my axes because I know that this, maybe if I go by 2s, this is my small. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. I'm going to put a point right there. Same thing on my big tables. I'll go by 2s. I'll go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I want to connect the dots. And everything in between represents all the possible tables, okay? Because you may choose, okay? All right? Michael, you may say, let's use 4, you with me? Yeah. Let's use 4 small tables and 16 big. Okay. And also it comes in, no, come on, do some feng shui with me. She might say, let's use 2, 4, 6, 8, 10, 12, 14, 16, 16. She might say, no, I want 16 small tables and 8 big tables. So that's why you have a line. This is all the combinations that you could make. You don't have to do just one or the other. There's lots of ways. So that's what the line represents. All the different combinations. Okay? Sorry I took up a lot of your time today, but it was kind of fun. Today's homework is not that hard. Page 77. And we're going to do, and 78. We're going to do 1 through 8 all.